Nice to meet you all, and thank you for coming. Our goal for today's webinar is to cover and piece together the different ways to acquire data using RULA hardware and software. So let's just take a look at the plan of the webinar first. We'll begin with an overview of all RULA devices you can use for data acquisition, both in a lab and in the field. I will also highlight the most important features of every device related to data acquisition, what sensors you can connect, what data you can record, and so on. Before we get to the practical part, I will briefly summarize and compare all crucial information about each type of dock at our disposal. In the second part, we'll take a brief look at the available options of our data analysis software and its interface. Then we'll use it to record data from two of our devices, IOC21, it's on down below, and RLR19, a portable spectrum analyzer, and perform basic spectrum calculation and filtering on the files. I will also touch upon our internal format, our effects, and how you can easily convert it to any of the international formats in this analyzer. In the last part, I will try to answer any additional questions you might have. And I'd also like to finish the webinar with some questions to you viewers. All webinar participants will also receive a short guidebook on our data acquisition options and the webinar presentation. And without further ado, let's begin. So as you might know, RULA operates in three main fields: vibration testing, accelerometer calibration, and data acquisition. Vibration testing is our main profile, and we have the most active. However, we also dedicate a lot of time and resources to produce affordable and adaptable data acquisition systems. To just visualize the structure of a product range, I've divided all products into two distinct groups. You can see them on the slide. That's the laboratory devices and the devices for field operation. Let's just begin with the first group. The range of laboratory devices is comprised entirely of vibration controllers. One of the biggest of our system is their flexibility in a universal application. So RULA software has a modular structure, which means you can begin with a basic setup and upgrade as you go. And thanks to that, each controller can function as a part of the vibration testing system, a system for accelerometer calibration, or as an instrument for data acquisition. So let's just take a look at each of the three controllers you can use to acquire data, understand the difference between them, and highlight some key features. Let's begin with RLC25. This is the controller designed with data acquisition in mind, and the only one you can use without analog outputs. So this is the system we offer to our clients when they need to read data from a large number of channels. It has a convenient modular structure with 3 module types, 8 analog inputs, 4 analog outputs, and 8 strain gauge inputs. You can upgrade the system or swap the modules around, provided you have space left in the chassis. And the DAQ has BNC inputs and outputs for non-strain sensors and RJ45 type inputs for strain gauge measurement. The strain gauge module provides configurable bridge as well. You can scale the system up to 512 channels by interconnecting 22 units. It has frequency range from DC to 106 kHz and a configurable sample rate up to 265 kHz. The system supports the following types of inputs: IEPE, linear, TEDS, charge, and strain gauge. You can view and record acceleration, displacement, velocity, DC voltage and current, charge, and strain data, etc. Also, we work with climatic chambers using the Modbus TCP protocol, and you can read temperature and humidity data from them. However, this data will not be recorded in file, only used in the report in the form of graphs. Additionally, we have 2 vibration control systems that can be used as supplementary means of recording data. So let's just quickly go over them. The first one being IOC21, and this is our staple vibration controller that has 4 inputs and 2 outputs in one box by default. You can scale it up to 32 channels and measure data in the frequency range from 0.1 Hz to 35 kHz, with a configurable sample rate up to 108 kHz. It supports the same type of sensors and can process the same types of data as ROC25, excluding the current and voltage measurements. However, this may not be the most optimal device to acquire data because of its limited number of channels. But it's a valid option if your laboratory or research and development department mainly performs vibration tests and you sometimes just need to acquire and process data on the side. Let's move on to RLC21M. This is an upgraded version of RLC21 that features 8 channels in one box and up to 64 input channels with interconnected units. It has a frequency range from DC to 80 kHz and a sample rate up to 216 kHz. You can connect thermocouples and thermistor sensors to it, although the data, again, will not be written to file and available on the graphs and reports. But you can also measure DC current and DC voltage. The system can be used as a supplementary means of acquiring data, and it is more suitable for complex projects thanks to the increased number of channels and more options for recording data. Now to move to the field devices we have at our disposal. They are autonomous hardware that can be used in harsh environment thanks to the IP65 protection rating and a lack of fragile parts. So the first one being RLR19. This is a portable spectrum analyzer and data acquisition system. You can see it on the webcam on the left, right here. It has up to 8 measuring channels, and you can sync 4 devices to get 32 channels out of it. Frequency ranges from DC to 60 kHz, with a sample rate up to 144 kHz. RLR19 can function autonomously and record data using the internal software, or work online while connected to the PC. The device works with IP, TEDs, and linear sensors by default. You can also connect a charge sensor using an external amplifier. RLR19 can record the following types of data in the internal memory: acceleration, velocity, displacement, temperature, force, current and voltage, and strain using a strain gauge amplifier. The internal software also has a modular structure with several options available that you can see on the screen right now. This includes basic software like oscilloscope and RMS and TGD measurement, data recording, helicopter application, which is one of the main ones, I should say. So blade tracking and balancing, various types of analysis like spectrum analysis and statistical measurements, digital filtering, and the ability to replicate the signal, the recorded signal, using the output in the repeater mode. Let's move on to RLR17, which is our portable autonomous shock recorder. It's simple yet easy to use and quite powerful and well protected. It also has its own software, which comes for free with the device. There you can configure the device, export and visualize data, and some basic calculations. The device has an embedded 3-axle accelerometer and covers a frequency range from 0.1 to 800 Hz with a sample rate from 50 to 3200 Hz. It records timestamp data to the internal memory. We can also record temperature with it, and currently we're planning to upgrade the device to include humidity measurements. Now to just draw a basic conclusion to this part, we have 5 devices in total that can be used to acquire data. 3 of them are vibration controllers, are mainly used in lab environment, with RLC25 being the most suitable for acquiring data from a larger number of sensors. 2 devices are portable and autonomous, and thus well suited to field work in harsh environment, thanks to their high protection rating. Our controller-based devices support all of the most popular input types: IEP, linear, charge, and strain gauge. You can see a comparison table on the screen right now, and you will get it in the follow-up email after the webinar. You can view and record acceleration, displacement, velocity, DC voltage and current, charge and strain data, etc. You can also view temperature and humidity data by using the system with a climatic chamber. However, we don't record this data to file for now. If you have any questions right now, I'll be happy to answer them. Okay, you mentioned that this strain gauge module of RLC25 allows you to configure bridge types, but what about amplification? The amplification is a factory preset for this module and is set depending on the needs of your project, basically. Can you repeat what the 8 input channels are on C25? How is it different than front end? We have 8 inputs, like 8 BNC inputs, we have 4 outputs, and we have 8 strain gauge inputs. So in here, I'm just showcasing the modules, but the device itself has three spaces basically in the chassis for modules. So you can technically install, for example, 8 inputs or 16 inputs and 4 outputs. You can install 8 normal inputs and 8 strain gauge and 4 outputs, etc. So you can mix and match depending on your needs. Okay, let's go to the next section. And this is the data analysis software overview. Our data analysis software allows you to record data from the inputs of all laboratory devices and while connected to PC RULA19, and then use the files to calculate spectra, perform waterfall, statistical and octave analysis, apply custom filters to the recorded data, and etc. Let's take a brief look at the available software options. So here we have a comparison tab of all options that can work online and offline. By offline, I mean working with files, and by online, I mean connecting the device to the PC. So some of those options are available in both modes, and in key, those are spectrum calculation, octave, statistical, and waterfall analysis, and filtering. Some of those are unique to either online or offline mode. So for online, we have recording, which I'm going to showcase, oscilloscope, and sensor calibration. For offline mode, we have modal analysis, cross-spectrum, arithmetic operations, editing files, performing TECO analysis, blade balancing and blade tracking, and shock response spectrum. I'll not be going too deep into the options during this webinar because it would just take a lot of time. And if you're interested, we could plan another webinar on the data analysis software in particular and just look at it in more detail. For the purposes of demonstration, however, we'll use the files we record to calculate basic spectrum and apply a custom filter to files. Now let's just move on to the recording part. In this webinar, I would like to show you how to record with ROC21, but this procedure is pretty much the same for any other controller or data acquisition system I've mentioned. Turn on the device, which I've already done, and you need to connect your sensor to the input you want to record from. So in our case, let me just show it. I'll be using a regular IPE accelerometer with sensitivity 10 millivolts per G, and it will be on channel 1. Next step is to connect your device to PC or laptop using the Ethernet cable. So I've just showcased it on the presentation. Then let's actually go into the software. So here's how the main window looks like. It's set up pretty much in the same way as our regression testing software. We have 3 main tabs here: analysis with all the analysis types, configuration for setting the measurement units, mode, and finding the device, and devices for using RLR19, generating reports, and managing its files. So for this one, we'll first need to check that we are in the online mode. This button right here, blue button with this analyzer on it, switches the modes. So the first mode here, file, is for offline analysis, and we're in it right now. Devices is for online analysis. These 2 modes right here are for model analysis, and we've already covered them in one of our previous webinars, which is available, by the way, on our channel. Let's just switch to devices mode and establish the connection between our controller and our PC. So right now we are in the devices mode. As you can see, we have the online analysis panel here on the left. So in here, to connect the device, we will first need to go to configuration and press hardware. It will search for the controller and allow us to establish the connection. If everything is connected correctly, you will see the device in the list right here. Next, we need to go to the settings window by pressing the settings button. And here we have some options to configure the input channels. So in our case, it's IEPE acceleration in G units with a sensitivity of 10 millivolts per G. Here we can choose a number of input types and dimensions, as you can see. We also have the means to save this configuration or add new configurations, or export and import data from the sensor configuration to share it with your colleagues or just take it with you. We can also read TEDs if you're using this type of sensors. Once we've set up the channel, we can go to the Record tab. Here we press Browse and set the name and the folder of the file. So in our case, let it be webinar doc. After that, we check the box with the channel we want to record from, and we select automatically add date and time to record file name. Then it will be added to the recording so you can easily recognize it. With all that done, press apply and OK, and press start to start the online analysis. So it will establish the connection between the controller and the PC. Next, we just have 2 more steps to complete the recording. So it's not complicated at all here. Press record on the analysis tab, press start, and we can generate some input. Let's press stop. By the way, if you want to check the input beforehand, you can use stuff like oscilloscope, for example, to check the info. So in our case, we are seeing channel 1, and we can scale it or do the spectrum scope. And if we tap on the sensor, we can see the input. So with that recorded, we can stop the online analysis and switch to the file mode by pressing on the file. In here on the left, you see the signals and results tab. This is where the files will go after we import them. So we press on the add file button, select the file we've recorded, open it. It will be exported as imported as a folder. Then we can highlight and hover over it to see some info like time of the recording, duration, sensors, etc. And then if you double click, you will see the signal scope. So this is what it looks like in here. Working with graphs in our visualizer is quite similar to working with it in RULA vibration testing software. You can add lines, you can add notes, you can add data cursors, etc. Let's make some basic analysis with it and calculate a spectrum. So just press on the spectrum button, check the channel you want to record from, check the type and averaging type, press OK, and you have your spectrum right here. Then let's apply some custom filtering, for example, low pass, to filter the higher frequencies. Let's choose the filter type, for example, IIR, and cut off all frequencies that are above 1000 Hertz, for example. It's quite useful if you are using some ISO standards, right, or mil-STD. So usually with those, you want to filter the high frequencies to avoid unnecessarily high acceleration values. Let's do that. And let's auto scale. Here we go. So we can drag and drop the window to compare them, or we can just arrange graphs in adaptive style and display them all on the screen at the same time. So with that out of the way, let's move on to the second device I'd like to showcase, and this is RULA-R19. The process is a bit more complicated with it, as with RLC21, but it's nothing too difficult. So in here, first things first, we will need to connect the accelerometer to the adapter we provide. Then we will need to connect our device to the Ethernet socket on our laptop. So let me just briefly, so this was the one for RLC21, just a normal Ethernet. And here we have an Ethernet like this, and it's connected to one of the on the device on one end and to the PC on the other. So let's configure some settings in here. First things first, we need to go to channels, and we need to configure this first line in here. I'm not sure if you will see it, but here we have the channel setup. So in our case, we're using IEEE, units are G, and sensitivity is 10 millivolts per G. Once we are satisfied with it, we press on the back, measurements, and in here we have a window that allows us to preview the input. So pretest, for example, but this is not the recording yet. So let's stop it and press the recording button. As you can see, the LED light of the recording will blink. So let's just generate some input. If you want to press the recording, stop the recording, just press the stop. And then we will need to go to FTP. So we are using the Ethernet cable or the FTP connection to drop the files to our PC, but we also have a memory card inside. So if you have a memory card adapter, you can also use it to quickly transfer the files without the need to connect it with an Ethernet. So press OK on the FTP. It will give you access to the files. And now let's go back to our VIS analyzer. In here, make sure that you are in the helicopter mode. So our software has two modes, common and helicopter. And for helicopter, you have access to additional modules like blade tracking and balancing, for example, or takeoff analysis. So we're currently in it. And we have this tab devices right here. Press file management. It will find the device. And if everything is all right, you will see it on screen. Double click the RULA-R19 and you will access the FTP folder of the hardware. Then you can record, import by itself. You can double click and choose the recording you want. So in our case, it will be this one. So let's download it by checking the box. Choose the folder you want to download it to. And it will be downloading. Can you export that PSD and then re-import it into VisProbe software to run it as a random test? Yes. So you can export it and use it to generate a spectrum and then run it, for example, in field data replication. Once we're finished with this, let's go back to analysis. In here, we can add files. Select the one you've just imported. Open the folder. Select channel 1. And in here, you have your recording. Again, you can do anything you really want with it, but I won't go too deep into it. One last point I wanted to cover, just to clear some misunderstandings, is the point of our native data format, which is VARFX. So as you can see, as you may have seen, it's recorded in another format. And let me just go back to the presentation right now. So this format is quite similar in structure to CSV, but it's not a line format. So it actually stores all data, all settings of the recording, channel types, input types, etc. And it's optimized to work better with our software and hardware. But it's quite easy to export it to any of the international formats, for example, MATLAB, UFF, CSV, etc. So let me just quickly show how to do that. Hover over export, you actually have the option to export it in any format you desire. Also, we have some other ways to do that that are not quite as obvious, but we have an option to save data to CSV by right-clicking the graph, or you can and then just paste it into any text editor you have. It's not quite as efficient, but it's a way. All right. I believe you also had some more questions. Does RLR19 have a touch screen? Yes, that's a great question. Not the old model I'm showing you right now. It has the manual buttons, which has its own advantage of not breaking if you're using it in the cold environment, for example. But the new models will be launching somewhere in 2023. We'll have a touch screen indeed. One other question, can you record using Bisprobe SL, so our vibration testing software? Yes, you actually can. You can use this software and to record data in the VARFX format again. However, we didn't highlight it in this webinar to just avoid confusion. It's usually used with the supplementary means of recording data like RLC21 and RLC21M. And for any other applications, we highly advise to use this analyzer. Now, do you guys have any other questions? Okay, I believe this would be all for today. I'd like to end this webinar with another question to you. So we posted a request for topics in our LinkedIn, I believe last webinar, but I just wanted to ask this live. So if you have any particular needs or projects you would like us to cover, do write them in chat right now or just mail us, and we will organize a webinar on your request or your topic. It's contact@rulatech.com. Keep your emails open for short follow-up, and thank you for participation. Thank you, guys. Have a nice day. Bye-bye.